Okay, in the lab today, we're going to use a pH probe to determine the pKa of an actual acid. The acid that we're going to be testing is acetic acid. And the chart I have on this page, the graph of pH to the volume of NaOH added, is exactly what we get if we were to just put in drop by drop by drop and actually measure the pH. Now this one was calculated, and we'll see in class later on how to get all those data points so you could calculate it on your own. But I had this on here just to show 2 points because technically speaking, when we get to the data sheet on this, there really is just 2 pieces of experimental data we get. An equivalence point pH and the half titration point pH. Alright, now the equivalence point really is just where the titration is neutralized. So what we're going to have is we're going to have in a Erlenmeyer flask some acetic acid, and then we're going to titrate into it some sodium hydroxide, and we'll see the pH gradually go up. And we're going to put some phenolphthalein in it and stop when that solution just turns pink, right, with a drop of sodium hydroxide. And that's going to be somewhere in this area. Now, it should be about equal amounts, so since we're going to be using 10 milliliters of acetic acid, it should only be about 10 milliliters of NaOH. Now, that's going to vary some because these concentrations aren't super accurate on this lab. They were just mostly close. So it's about equal amounts. So we are going to go nice and drop by drop by drop. Now what's interesting, we will see the pH here varies between our 2 runs more often than not, and that's simply because this really is, that whole vertical line from a pH of 6 to 12, that happens in a few drops, well less than a milliliter. And just in a few drops you get that drastic change. So a drop of NaOH at that point has a drastic effect on the pH. So our pH at the equivalent point will be varied, and we're okay with that. The one we want to be stable is the half point. And how we're going to get this and know it's exactly halfway between here and here is we're going to put just 10 milliliters of acetic acid in there and then titrate it to its equivalence point. And then we're going to put another 10 milliliters of acetic acid in there to cut the concentration right back in half. And that's how we're going to get that equivalence point, or the pKa, because that's going to be that middle point. So as much as this first number is going to jump around, as in the equivalence point pH, it's going to jump around, this is going to be almost dead on exactly the same. And we're hoping, since this is vinegar, to have a pKa around 4.7. And we'll see how we do when we get to the lab.